Hello. Should be live. Uh-oh. Hello. Should be live. Nice. Uh-oh. Cool. That works. Alright. I got my mic close to my face and I can't see anymore. And my music on in the background for fun. It's at 4%. That is low. So, yeah. Tic-tac-toe reinforcement learning. We shall see. I'm just copy and pasting all the code so far. You know. Uh-oh, nope, not touching that. Why is this music so loud? It's at 4. 1. You're at 1. That's much better for my ears. You guys can probably barely hear it. There we go. Alright, looks like we're gonna have a player. Do in Python. Yeah. Capitals. Okay, I'm gonna basically copy over all this code and then stare at it. How do I indent? Is this? It's like yeah. P1 available position. Oh, this is under game, isn't it? Yeah. Oh, yeah. Okay. Oh, yeah, it tells me where to put things. Hold on. Okay. Actually, there's also a link to where all this code should be. I'm gonna just copy the code from here. What is pickle? Okay. What the hell is pickle? I need to get pickle now. Can I just create and I'll add it to it? We'll find out. What do you want? Can't find pickle? It probably can't find pickle. My guess is that pickle is... It looks like I already have it. And it's not complaining, so it must be part of like Matplotlib or NumPy. Okay, let's stare at this code. And also I'll have it open this monitor over here for explaining what each part does. Firstly, train 2 agents to play against each other and save their policy. Secondly, load the policy and make the agent to play against human. Alright, that's the goal. Now, how are we going to do that? That's the question. State setting. We need a state class to act as both board and judger. Oh. So the game is called state. Okay, I guess that works. That's a little odd. But it works enough. Cool. Need a state class. Its functions recording board state of both players and updating the state when either player takes an action. Meanwhile, it's able to judge the end of the game and give reward to players accordingly. Cool. Hold on. Alright, formulate the... I can bring this onto the... Oh no. I'll bring this over onto the main page so we can read what we're doing. To formulate the reinforcement learning problem is the most important thing. Is to be clear about 3 major components: state, action, and reward. State of the game is, you know, the board. So it's a 3x3 board with zeros indicating available positions, and updating the board. Update positions with 1 if player 1 makes a move, and -1 if player 2 takes a move. Huh? So we will initialize a 3x3 board with zeros indicating available positions, and update positions with 1 if player 1 takes a move, and -1 if player 2 takes a move. So is that just like the X's and O's? Yeah, okay. Cool. The action is what positions a player can choose based on a current board state. Reward is between 0 and 1, and it's only given at the end of the game. Really? That would make sense, because you can only win at the end of the game. You can't win prior. In it. Okay, so this is for the board. New board. It's 3 and 3. Self P1 is P1, self P2 is P2, self is end? Is end? Who told you booleans? Why is end? Why not like is running? I guess you can do that. Whatever. Self board hash. This is going to be the hash of the current state of the board, because someone was smart and decided that in the queue table, instead of having a state be the entire board, it's going to be the hash of a board, because smart and not dumb like my brain was thinking. Self player symbol 1. So we're starting on 1. Yeah, we initialize a vacant board with player 1 and 2. Player 1 goes first. Each player has a play symbol where a player will take an action. Its player symbol will be filled in with the board, to the board, and the state will be updated. Okay, I'm not sure what the reshape function does, but it looks like it goes into creating the hash. Unless we make it. Numpy. Gives a new shape to the array without changing its data. What does that, like, imply? Oh, I'm reshaping it into one array. I guess. Yeah. Wait. I see no examples. Wait, no. Board.reshape. I'm seeing np.reshape for numpy. Or numpy. I say numpy. Numpy's fun to say. I got a text. Hold on. That's Snapchat. Go away, Snapchat. No one likes you. Okay. Function hashes the current board. How? It looks like it just puts it into an array and then sets that to a string, and that's the hash. I mean, I guess that is a hash. Like, it is identifiable. It's like, you know, different than every other board state, but when a player takes an action, its corresponding symbol will be filled in the board after the state being updated. The board will also update the current vacant positions on the board and feed it back to the next player in turn. In turn, yeah, sure. Available positions. If it's a 0, add it. Need to be a tuple. Okay. Because you did it that way, yeah. I guess. Update state self position. Self.board position equals self player symbol. Okay. Self player symbol -1 if self player symbol equals 1 else 1. If player 1 set to -1. Oh, yeah, switching turns. You're right. That is, is that a freaking Java, Python ternary operator? That's, I mean, that is nasty. I much prefer the other one. Just because Python's ugly, not gonna lie. Python is nasty sometimes. Okay. This is just the game itself. Def winner. Board rows. Alright, go for every row. If you add them up in the 3, you're good. Yeah, oh, that's an interesting way of doing it, just adding them all up. And seeing if they're 3 or -3. And this is a tie. This is definitely a way to do it. I might steal this for when we do Connect 4. Give reward. Feed reward. That's definitely an interesting thing. Result equals self.winner. Because that gets sent, that gets set. Where does it get sent? I'd assume it. Oh, it's function. I'm freaking dumb. Don't worry about it. Okay. If result is 1, self P1 feed reward 1. Self P feed reward 0. And then 0, 1. And then if it's a tie, player 1 gets 0.1 and player 2 gets 0.5. For reasons? Yeah, 0 if draw and none if the game is not ended yet. So why are you setting 0.1? One thing notice that we consider draw is also a bad end, so we give our agent 0.1, even though it's a tie. So this is our agent. P1 is the agent. P2 is the other agent. Because I think we're making it play against each other, no? Alright, here's our player. here we go. We got some fun stuff. Self, name, expiration rate. No, that's not what that says. What is that? Exploration versus exploitation. This is random choice. This is prior choice that is best. Self.states is all the possible states that it goes and takes. Corresponding states, self-states value. What are you? Oh, state value pairs. You're right. Why do you have a states array when you have a state value pair dictionary? We use greedy method to balance between exploration. Here we set it to 3, which starts at 3, goes to 70. 70% of the time it'll take the greedy action, which is choosing the action based on the current estimation of the state's value. And 30% of the time it'll take a random action. Okay, this is the Q-learning algorithm. So the value of the state is the value of the state plus alpha, which is the learning rate, times the next state, value of the next state minus the value of the current state. So it's the difference in the states times the learning rate plus the current state. And that will be in the feed reward for the AI question mark? Hold on. Human player. Ah. So player is the AI. Human player is the human player. Someone made a good decision. If I was Java Brain, I would say that you should do abstract classes or interfaces, but this is Python, and abstract classes are weird. Abstraction in general is weird in Python. Not abstraction, inheritance. Okay, so feed reward, self reward for ST in reversed states. Okay, backwards. If self.states value is get st is none, set it to 0. Here's the math. Self.decay gamma. Hello. Were you talked about? Am I blind? What is decay gamma? You didn't even talk about it. What the hell is decay gamma? Hold on. Oh. So this is decay of something. For some reason, there's a, what's the, So the actual equation is funky looking. It looks different a lot of things. So it's usually, okay, I like this. So it's the quality of the current state action is set to the quality of the current state action plus the learning rate times the reward plus Gamma, which is the discount rate, 99% off, of Max the Prime. I don't know why it's maxed. But that, some of them don't say max, like this one. It's just multiplying it by prime, and where prime is the next one. Question mark. I don't know. Anyway, it's some sort of decay on reward, so maybe it doesn't do as well over time, or maybe it doesn't change the rewards as much over time. Positions of the game are stored in self states, and when the agent reaches the end of the game, the estimates are updated in reversed fashion. For I don't know why. Now that our agent's able to learn by updating value estimation and the board is all set up, it's time to let two players play against each other. This part is put inside the state class. Play. 100 rounds. Why is it not called train? I don't want to play 100 rounds against... Oh, it's a parameter. You're right. Well, not end. Positions. Get action. Update state. Get the hash. Add the state. Check if winner. If there's a winner, do the rewards. Else, it goes to player 2. I guess you could do that back and forth thing. I don't particularly enjoy that though, because these are this is the same code. Why don't you just flip flop? Do you not have a current player? P1 and P2. Yeah, but state has a, I guess it has a player symbol. I don't know. During training process for each player, look for available positions, choose an action, update board state, and add the action to the player states. Judge if reach the end of the game and give reward accordingly. Saving and loading the policy. Where is that going to be? Is that going to be in player? Yeah. So it's going to be stored in policy dot name. There's no extension. Okay. Human versus computer. This is what the human does. Create reward, nothing. Add state, nothing. Reset, pass. Modify a bit on the play function inside state. Why? Play 2? Play against a human. Why do you have 2 functions? Bro, who wrote this? Someone smarter than me? Probably. This is funky. I don't know who decided to have 2 different play functions and name them play and play 2, which is terrible. Wins. So this one isn't doing learning. It's not actually learning from this. I can run it. Actually, yeah, let's see. What's it gonna actually do? Player, two AIs. State. Play 50,000 times. Play with a human. Load the policy, because it will save to P1. And then human. Yeah, we could try it. Python. Tic-tac-toe. Oh. It's cranking. Alright. It is cranking through. So the play function, at the end of the play function, where does it save policy? That's a problem. So it never saves policy. It never saves the policy. I don't know who wrote this code. I'm not shitting on them because I currently can't do this because I'm learning. But what the hell? Hi, Jeremy Zhang. Why don't you ever call save policy? What you call load is not gonna just crash because it's never gonna be saved. Guess we'll find out. $50,000 immediately crashes. Yep. Save policy doesn't take any. Yeah, it doesn't. Alright, we're gonna play against it. It's gonna be really shit. It's gonna play 10 times. Okay. It didn't put anything in the middle. Action row, 1, yeah. 0, 2. You lost. How do you feel? Action row 2, 0. Bam. Alright, now let's up that to 100 and see if it's any better. You still didn't put anything in the middle. And I don't know what you're trying to do here. It's trying to trick me or something. Right? It's played 100 games of tic-tac-toe. 0, 3. 0, 2. You lost again. Wow. 1,000? You're slow. Then again, tic-tac-toe is definitely a game. Alright, you put it in the middle. Hold on. I just want to make sure that's not a fluke. Okay. Okay. 2, 0. 1, 2. Yeah. Oh, it tied me. Alright. It's pretty good. Tie. Be 2, 1. What about 0, 2? I put it in the wrong place. Damn it. 1, 0. Okay. So it actually just got good. Oh, that's so cool. What does the policy look like? Understandable. This is every possible state. I'm not sure what the extra random shit is, but it's every possible state and every value associated with that state. Okay, that's cool. Easy, you know, I just copied this, so I'm gonna have to figure out. I guess I don't, what does its state table look like? It just makes it, doesn't it? Yeah. I don't particularly know how this works. Like, I have an idea. But I wish I could see what these looked like and why you have different state value lists. You have one as a dict, and then you have one as a list, and I don't know why they aren't just one thing. I put it in the wrong place. It also just failed to win, and I just won. Homie, you're bad. Okay, yeah. Let me dump this up to the 10,000. That's crazy though. It didn't save the policy. I don't know why. The code that it came with crashed when you ran it. That's a no-go. Okay. It didn't start in the middle. 10,000 games, and it doesn't know that starting in the middle's pretty good. But maybe it doesn't care. Maybe that's fake. Tie. Alright. Alright, come on. Oh, I don't need to train it. You're right. Because I have the policy, I can then load the policy. You're right. Alright, let's put it in the middle. Row 1 or 2. Yeah, it's a tie. Okay. Okay. Alright, so it'll do the same thing unless I do different stuff. Let me try the 50,000 that came with, and we'll just wait. And then I'm gonna make some other stuff with this. Now that I'm sort of understanding how this works. Oh, that is loud for the microphone. I didn't realize that. I just saw it like spiking over there. Hello, Crusader. I know who you are. What's poppin'? I am making reinforcement learning AI learn how to play tic-tac-toe. It is currently tryharding through 50,000 games to see what's good or not. And then I'm gonna probably try to figure out how to make my own with this as a reference, just because I want to get used to figuring out how to use this. It's probably simpler than tic-tac-toe. I have two theoretical games in mind. There's a game called Pick 5 where you pick a number 1 through 10, and if you pick 5, you win. So eventually I think it'll be pretty good at picking the number 5. And then the next one is going to be Pick Opposite, which is if one player picks 3, it should pick the opposite, which is in comparison to 5. So if you pick 3, it'll pick 7. If you pick 1, it'll pick 9, etc. So those are like the two ideas that I have for making my own versions of this, because I don't want to just copy and paste an entire 200 and almost 300 line program and just say I did it, because not really. Okay, so now I'm gonna do row 2. Yeah, there. It's good. I say it's good. I don't know if it's that good. What I will do is stop it from training again. But it's just going to always start in the middle. It's not random once it's trained. That's the thing. It's going to start in the middle. And then maybe if I pick the bottom right, picks there. Nice. 0, 2, 1, 0, 0, 1. All right. Okay, it's pretty much just consistently tying me in tic-tac-toe. Tic-tac-toe is simple. We're gonna get to Connect 4 eventually, but tic-tac-toe in the bag. I'm gonna try pick 5. Okay. I'm going to copy all of this. And then okay, port calls is going to equal, so there's 0, I want 0 through 9, so I can just do 9, 10. Winner, do I even need this? Yeah, have you seen the stand-up math video where they had a bunch of matchboxes learn to play tic-tac-toe? Matchboxes? Like cars? Or like boxes of matches? What do you mean? And no, I haven't seen it. if you're still wondering after those 2 comments. What? Player is good. I don't need human player for this, because it's game. It's pick 5. If you pick 5, you win. So it's not particularly tough. complicated to explain in chat, but they basically manually did reinforcement learning where each box corresponded to a game state, and you'd randomly draw another game state from the box. I'm not exactly wrapping my head around what you're saying, but it sounds interesting. I think I have some concept of what you're saying. Okay. So now we need to remake the game. So it's basically going to be, it's going to get an input. Self.input equals -1. Don't put a semicolon. But if that game lost, they'd remove this stuff from the box such that it'd be less likely to make those moves in future games. Yeah. That's cool. Okay. If self.input equals 5, return 1, else return -1. Nice. Available positions. Yeah. I need equals. I'm potato. I'm a coder. Come on. Why did I not know that? Also. Oh. I don't know what the hash for the state would be because there's one state. You're gonna bounce. Catch you later. All right. See ya. I'll be doing this for a little bit. All right. Your hash will be -1 because that's the only state. There's one state, and it's starting with input being -1. Ah. Huh. Give reward. Oh yeah, I also need the player. Self.player. Player. Cool. Semicolon. I'm in JavaScript brain. Okay. Give reward. What did this one do for give reward? Give the result. Okay. And then player.feed reward result. Yeah. Update state. That works. Reset. Yeah, that's it. It's a very simple game. I don't need to show the board because there isn't a board. Why does player have a get hash? If I remove this, are there any red lines? No. That's good. Choose action. Sure. I'm not going to touch that. What happens if I run this? Play. I don't need play 2. Go away, play 2. Oh, this is going to explode. Okay. Player. Oops. Does player have add state? Yeah, probably. Oh. Okay, player does need the hash. Where's your code? Your code is down here. Oh, I have your code. Freaking right here. Player, get hash. Input. Ultra brain. What happens when I run this? It's probably going to crash. Yeah. You don't need name. Yeah, you need... There's one state. We're gonna see what happens with this. It died. Oh yeah, now you need self. Yeah, what else do you need? It didn't die. Its policy looks intriguing. And it played 50,000 rounds very quickly. What does play return? I only need to do like 10. I'm gonna do 10. And then for every round, I want to print out what it picked. All right. It's really bad. It picked a bunch of 9s. All right, maybe 10 isn't enough. Let me give it 1,000. I'm definitely doing something wrong. I'm seeing an abundance of 9s. 10,000? Is that better? No, but it really likes picking 9. Which is not the number that wins, by the way. The number that wins is 5. What does the policy look like? I assume if this is something, it goes, if -1, pick 9. It's my guess. I don't know why it's picking 9. Also, there's an extra comma here. It's weird to do this with only one state, given how it must not be doing what I think it's doing. It must be like blowing up and being like, what? I don't know what's going on. Nile Red turning paint thinner into cherry soda. Okay, that's a video to watch later. Yeah, and then I want to add 1 to all. Yep. And I'm going to print it. It picked it picked 9 a lot. Understood. Huh. That's funny. Alright. I am gonna be done for now. So, for anybody watching, I'll peace out, and I'll probably do this later when I actually know what I'm doing. I don't know if this is entertaining at all, but it's kind of funny. Anyway, peace.